All right, here we go. This is our Unit 5 test review. Man, can you guys believe it? We're almost at the end of the semester. 5 units down, one to go. This was all about like triangles and relationships inside of triangles. We did a lot of graphing. We did a few proofs, not too many proofs, with triangles. But one of the very first things we did prove, and we actually talked about this in Unit 4, was isosceles triangles. What is an isosceles triangle? Well, the definition of an isosceles triangle is a triangle where two sides are congruent. Now, we proved that if you have an isosceles triangle, then we get, for free, two congruent angles, right? It's the two congruent angles are across from the congruent sides. We call those the base angles, right? And then this guy up top, we call the vertex angle. Now, if we look at this picture, we do have an isosceles triangle because we have two congruent angles. So what we can do is we can set these two pieces together. We have to be careful. Like, look at the way the picture is oriented. The two congruent angles are not always the bottom two. This one, we got the top one and the left one. Look at the sides across from those angles. All right, so we know those sides are going to be congruent. So I'll put some tick marks on these sides. And when we have congruent sides, we set the expressions equal to each other. So this first one here is just 4x minus 6 equals 18. And we are solving this for x, right? So add your 6 over, we got 4x equals 24. Divide the 4 away, and we get an x equals 6, all right? And that one's done, right? So, all right, I think that's all I have to say about that one. So let's just look at the next one here. If angle 1 is 40 degrees, find all the other angles. So here's what I'm going to do. I am going to trace this out. All right. So if I look at this red triangle here, we know these two sides are congruent. Well, hey, guess what? We get these two angles are congruent. All right. So here is an angle 1. Here is an angle 2. They tell us angle 1 equals 40. So we automatically know angle 2 is 40. All right. Now, this angle down here, they don't tell us, they're not asking us to figure out what that angle is, but we do need to kind of figure out what this angle is. That is 100, and it's 100. All right, we know it's 100 because all three of those angles need to add up to 180. So with that in mind, if this right here is a 100-degree angle, what does that tell us about angle 3? All right, we know that angle 3 has to equal 80 degrees. All right, because again, those are a linear pair. So if we look at just this spot right here, that's a linear pair. So one side we got was 100, the other side has to be 80. So now here's what I'm going to do. I'm going to look at this other triangle. Maybe I'll do this one in green. No, how about purple? All right, so I have this triangle right here. I'm just going to trace it and I'm going to drag it over. So maybe that's cheating, maybe not. I don't know. It's fine. So this is an angle 3. This is an angle 5. This is an angle 4. And again, we know that these sides are congruent. So we have another isosceles triangle. So let's look at those sides across. These sides across from each other have to be congruent. So we know angle 5 equals angle 4. We already know angle 3. Angle 3 equals 80. So here, we can set up an equation, right? This is an 80-degree angle. We need to figure out the other one. So I'm going to call this guy x. And I'm going to call the other one x, right? Because angle 5 and 4, we don't know what they are. We just know they're equal. So let's make a formula, make an equation, I guess. We know x plus 80 equals 180. Right? Therefore, we can say 2x equals 100. And if 2x equals 100, then x is 50. Right? So I know that angle 4 equals 50 degrees, and I know angle 5 equals 50 degrees. All right, so that was number 2. A little bit more involved on number 2 there. All right. Moving right along, question number 3, equilateral triangle DEF. So here's what I'm going to do. I'm going to draw my best equilateral triangle. Here is D, here is E, here is F. Since it's equilateral, I'm going to put some tick marks, right? That's just, a reminder for me that we have 3 congruent sides. Well, if we have an equilateral triangle, we also have an equiangular triangle. All right, so every single one of those angles is 60 degrees. All right, so we could say angle E is 60. We could say angle D is 60. We could say angle F is also 60. All right, well, take a look. We know angle D is x plus y. We know angle D is 60. So I'm going to say x plus y equals 60. All right. Maybe in another color, we have angle E. Angle E is 2x minus y. I know angle E is also 60 degrees. So how about this? How about 2x minus y equals 60? Right? So this is a system of equations. Now, I know it's a system of equations because I have an x and y. Anytime you have 2 variables inside of an equation, it's kind of a red flag, all right, that we need to set up a system of equations. Now, if you look at this system, you'll notice, hey, I got a positive y and a negative y. They will cancel if I add them straight down. So let's do that. X plus 2x, well, that's just 3 x's. 60 plus 60 is 120. Therefore, x equals 40. All right, now, unfortunately, they're saying, hey, find the value of y. So what do we have to do? We have to plug it back in. Pick an equation, the top one, the bottom one, it doesn't matter. I kind of like the blue one more. It's a little bit easier. So I'm going to say, all right, x plus y equals 60. Well, guess what? We found what x was. X is just 40. So we got 40 plus y equals 60. Therefore, y is 20. Right? And that one's done. All right. On to the next one. Find the distance between 2 points. All right, we know the distance formula is equal to, we have an x2 minus an x1. We take x2 minus x1 and we square it. Then I'm going to take a y2 minus a y1. All right, I subtract the y values. And what am I going to do with those? I'm going to square those as well. All right, now, after I square them, I'm going to add them together. And then after I add them together, I'm going to square root that entire thing. All right, so that is our distance formula. So I'm going to label these. I'm going to call this x1, y1, and x2, y2. All right. I call it x1, y1 because that's just the first one listed out. All right. It really doesn't matter which one you pick. But now we can just plug it all in. So this is equal to the square root of, well, let's see here, x2 is -4. x1 is a 2. Right, plus y2, that's a 2, and y1, is a -1. So I'm minusing a negative. All right, so be careful on that one. We have to be very, very generous with our parentheses on these kinds of problems. All right, because someone, none of you guys, but somebody who probably isn't watching these videos is probably going to type this into their calculator incorrectly. All right, so 2 minus -1 is a positive 1, so that's a 3 squared. Now, from here, I've said this a million times. If you type in your calculator 6 squared or -6 squared, it's going to say -36. If you type in -6 in parentheses squared, that is +36. All right, we know anytime you square a number, it needs to be positive. Our calculator tends to make a mistake. It's kind of going order of operations. So we really have to be careful when we plug this in, right? So let's see here. I got square root of, I got 36 plus 9. 36 plus 9, well, that's just 45. So we got the square root of 45. All right. Now, what should we do from here? Don't give me a decimal, all right? we need to simplify this. Breaking down radicals, very useful. And you're going to see why when you kind of get to algebra 2 and maybe pre-calc. But what we need to do is we need to simplify this radical. All right, we need to divide 45 by some perfect squares. All right, when I say perfect squares, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and 4 times 4 is 16, 25, and so on and so forth, right? Always multiply by those perfect squares. Find a perfect square that will divide 45, all right? Some numbers do work. Some numbers you cannot simplify, and that's okay. But in this particular case, we can, right? 9 times 5 is 45. So it means the square root of 9 times the square root of 5 is the square root of 45. Well, what is the square root of 9? Square root of 9 is just a normal, regular 3. Square root of 5 is just some number. All right? I don't know what it is. 2 point something. All right. It's an ugly decimal. Let's figure out what that is. Square root of, let's get this out of here. The square root of 5. See, my face is in the way. The square root of 5 is 2.2. You know, that's ugly. Don't mess with that. Leave it like this. We try to avoid decimals. So this is what we call simplified radical form. All right. If you ever do want to check yourself, you can, right? So 3 square root of 5 as a decimal. 6.7, whatever. All right. Well, let's look at the square root of 45. That same thing should give us, if we do everything correctly, the same decimal, which it does, right? That's 6.708, right? We got that for both of them. All right, so that's how we can just kind of, confirm on our calculator here. All right, let's see here. Find the coordinates of a midpoint of a line segment that joins. All right, so I have 2 endpoints, and I need to find the point that's halfway between them. I know my x midpoint. All right, it's halfway between the 2 x values. All right, so it's going to be x1 plus x2. Well, anytime you want to find halfway between 2 numbers, you add them up and you divide by 2. All right, so I'm going to do that. Again, why don't I label these really quickly? I got x1, y1, and I got x2, y2. All right, so lots of formulas in this unit. We can say we got -3 plus 4 all over 2. That gives us a 1/2. All right. If you wanted to, you call it 0.5, I guess. I'm not going to like it, but you can call it a 0.5. So we know the x coordinate is 1/2. All right. I need to do the same thing with y values. So the y midpoint is just the sum of the y's. So 8 plus -2. If you want to say 8 minus 2, that's fine. Right? 8 minus 2 is 6. 6 divided by 2 gives us a 3. So our y coordinate is equal to 3. All right, so let's put those together. Remember, this is a midpoint. This is an ordered pair. So our midpoint here is just 1/2. And then you always separate them with a comma. All right, it's an ordered pair, so separate them with a comma. So this tells us the x midpoint is 1/2, and then the y coordinate, I guess, is 3. All right, the next one. They're telling us point K. Point K is the midpoint of AB, where we have the coordinates are 1, 1. We need to figure out the other one. So here, I'm going to draw kind of a line here. So if I look at this, right, this is point K. All right, point K, they're saying is right in the middle. And this is at -2, 4. All right, now the other one is down here. This is point A. All right, point A is at 1, -1. What they're doing is they're saying, hey, find the coordinate of B. Right? What is B? All right, so there's kind of two ways we could think about this. If it's a midpoint, these 2 segments are congruent, right? That's kind of the definition of the midpoint. So what I have to kind of do is we have to think, how do I go from one x value to the other? So how do I go from this +1 to a -2? Okay, what am I doing here? Well, if you look at them, I'm just subtracting a 3. So if I need to go backwards again, I'm just going to subtract a 3 again. So I'm just going to put a -3 right here. What is -2 minus 3? Well, that's just a -5. All right. Let's see here. On the next one, I have a -1 and I'm trying to get to a 4. So it looks like I'm going up. All right. So I'm adding a 5. All right. -1 plus 5 gives us 4. So let's do it again. 4 plus 5 gives us a 9. All right. So that other endpoint here, point B, that's just at -5, 9. All right. -5, 9. That's not a decimal. There we go. All right. So if you want to think about it visually or conceptually, that's how we would do it. Let's do it algebraically. Again, we know the x midpoint is equal to x1 plus y1. How about x1 plus x2 divided by 2. All right. We know this right here is our midpoint. This is our x midpoint. This is x1. So what I'm going to do is I'm going to plug them in and see what happens. I'm going to say, all right, how about this? How about -2 equals 1 plus x2 over 2. All right, and then what I do is I'm going to do some algebra, kind of work backwards. So multiply both sides by 2 here. We're going to get -4 equals the 2 in the denominator cancels. I got 1 plus x2. And then I'm going to subtract the 1 away. We're going to have, all right, that second x value is -5, which, hey, that matches up right here. And then we would just do the same thing with the y value. So again, the y midpoint, in this case, we're using the letter k. So I guess I should call y sub k. We got y1 plus y2 over 2, right? And then just throw all the numbers in here. So we have our y midpoint right here. We have our first y point right here. So plugging it all in, I got a 4. 4 equals -1 plus y2 over 2. Multiply both sides by 2. I'm going to skip that step. So we got 8 equals -1 plus y2. Therefore, y2 equals 9, which again is what we got right there. So there's 2 ways to do this problem. I don't care which way you do. Is one easier than the other? I don't know. I tend to like the algebra way. It's a little bit, more systematic. But if you just, conceptually, if you look at the picture on the left, if that makes more sense to you, then by all means do that, right? Whatever works for you is what's important. All right. I get 2 more, and then this first page will be done. Find the slope between 2 points. All right, so slope formula, another formula here. The slope, all right, we call it the rise over the run. That's going to be y2 minus y1 over x2 minus x1, right? How far apart are the y values? How far apart are the x values, right? The y values we associate with up and down, or the rise. The x values we associate with left and right, or the run. So again, just label them. I'm going to call this one x1, y1, and x2, y2. All right, for no reason other than just the order they are listed. So plugging this in, we got 3 minus 8. 3 minus 8 over 4 minus -1. All right, you could call it 4 plus 1 if you want, but sticking to the formula, that's what it's going to look like. So 3 minus 8 gives us a -5. 4 plus 1 gives us a +5. That simplifies down to -1 over 1, or simply just 1. It has a slope of -1. All right, so I think I did all of that correctly. I'm doing this for the first time, so I'm winging it here. All right, write the slope-intercept form. All right, slope-intercept form. This is y equals mx plus b. All right, so m represents the slope, b represents the intercept. All right, that's why we call it the slope-intercept form. Now, do they give us the slope? Well, yes, they do. All right, the slope is 4/5. So m equals 4/5. Do they give us an intercept? No, they give us a point. All right, they give us 5, 6. What is 5, 6? This is a point. I'm going to call this x1, y1. So they give us a point and they give us a slope. So you know what we're going to do is we're going to use the point slope formula. All right, I got y minus y1 equals m times x minus x1. I know in, 8th grade or middle school, we just hammer that red equation. All right, the y equals mx plus b. All right, it's a fine equation. There's nothing wrong with it. However, this purple one, the point slope, I do think is a little bit better. All right, so I would really recommend you, get used to using this point slope formula because we can get all of the other forms from this. All right, so here again, I'll just write it down. This is our point slope. All right. And let's plug everything in. So we have y minus 6. That equals our slope, which is 4/5. Right, and then we have x minus 5. Now, to go from point slope to y equals mx plus b. All right, we're trying to get to the red one. That's our end goal here. Just solve for y. All right, distribute, add the 6 over, call it a day. So the first thing I'm going to do is distribute the 4/5. So I got y minus 6 equals 4/5 x, right? Minus 4. 4/5 times 5 is 4. All right, then the last thing, let's just add the 6 over. All right, we got y equals 4/5 x plus 2. All right, and then there is our formula. This is our y equals mx plus b form. And this is done. All right, that was page 1. 1 page down. I think we got 3 to go. So, let's see here. Zoom updated, so I got to figure out how to stop recording now. But we'll see you guys in the next one.